Welcome. Dear students, today we are going to discuss about Hofmann rearrangement. Hofmann rearrangement involves the preparation of primary amine. Primary amine is made from acetylamide. Okay, we take an acetamide and we make a primary amine. That reaction is referred to as Hofmann rearrangement. So the product of the Hofmann rearrangement is a primary amine. Now, there are two things to be noted here. First, there is one carbon atom less in product than that of the reactant. One carbon atom less in the product than that of the reactant. And number second is, it only involves the removal of carbonyl group, nothing else. This group is removed, nothing else. So how do we make a primary amine from acetamide? Let us see, that is through Hofmann rearrangement reaction. For that, we use a primary this acetamide. We use an acetamide. We treat it with excess of bromine in alkaline medium, that is we take NaOH. Okay. Now we make the product, remove this carbonyl group and write primary amine. Okay, that is the main product, primary amine. Now take this Br2. We need to settle this Br2. Write 2NaBr. So Br2 is here. Here also there are two Br atoms. So that Br is settled. Okay. Now there are 2 sodium here. We have taken 2 sodium here. So there are 2 sodium here. Write this 2 sodium like this, Na2. Okay. Take this CO group from here. There is one CO group. Write that CO here. And take 2 oxygens from here. Okay. So that will lead you to NO2CO3. Now if you take 2 oxygen from here, how much oxygens are remaining? 2 oxygen. And how many hydrogens? 4 hydrogen. Now you just make it water. Okay. So that is a simple way to remember this reaction. Okay. It's no rocket science. Just take a primary amine, treat it with excess of bromine in alkaline medium, write primary amine first, then settle the Br2, write 2NaBr, 2Na is left, write Na2, take one CO, take 2 oxygen from here, 2 oxygens are remaining and 4 hydrogen, write it as water molecule. So that is a simple way to remember the reaction. Now let us understand the mechanism of Hofmann rearrangement. There are actually 4 steps in this mechanism. So I am going to write the 4 steps, but when I am writing the mechanism, I will not write 4 steps separately. I will orally say that 4 steps. Okay. So let us see the 4 steps. Step 1, formation of N-bromoamide. Second step, formation of acyl nitrile. Third step, formation of isocyanate. And last step, that is formation of primary amine. So these are the 4 steps: formation of N-bromoamide, formation of acyl nitrile, isocyanate, and lastly the formation of primary amine. Now let us see the mechanism. As I said, when I draw the mechanism, I will not subdivide it into steps. I will not write the subdivision. I will orally say it. Okay. Now for mechanism, let us now take the acetamide. We write the acetamide like this. So this is our acetamide, and nitrogen has got, as you know, a lone pair of electron. Okay. Now you react it with your alkali. Okay, NaOH. So OH minus is there. What would happen? This OH minus would take the H and water will be formed, and this pair of electron, these two electrons, they will remain here. That is, H will not take its electron, so that electron will come here. So what you get is like this. So this is the lone pair, and these are the bond pairs, and here is the H. Okay, so that is the first step. Now the first product is not formed. The first product is N-bromo amide. So we will form that. Now what is there present in the reaction other than that? Br2, correct? Br2 is actually non-polar in nature, but when it comes in the near vicinity of this, it develops positive and negative charges. The side which comes to this becomes positive and the side which is away becomes negative, and this Br now goes for like this. So now what we get is RCON. This is the lone pair. The bond pair has been occupied, and you get like this. So this is your first N-bromo amide or acid amide. So this is your first product. So the first step is completed. Now let us go for the second step. For this, treat it again with OH minus. The OH minus will do this job. It will take H, but when the H goes, its electron it would not take, and you get like this. Now I want to mention here that assume that H is going. Okay, I rub this H and it goes with OH to become H2O. Okay, and it leaves its electron here. Okay, so there will be one electron of nitrogen, one electron of H. Okay, if it leaves its electron here, see, the valency of nitrogen is actually 3. Okay, so let us see, forget about this pair, this is the lone pair. Okay, let us see this. This is 1, 2, 3, 4. So actually there should be 3 electrons in the outermost shell, but here there are 4 electrons. So this situation is actually very unstable, and therefore the Br takes its electron. Okay, and Br minus also leaves this. Okay, so now what you get is a lone pair is here still, and there is a bond pair here, right? This bond pair is still here. I have written it here. Okay, so this is the scenario that we are in right now. So this is acyl nitrile. So we are now completed the second step. Okay, now let us go to the third step. Now what would happen? Look at the bond pairs of nitrogen. There is 1 electron, 2 and 3. Forget about this. This is the lone pair of electron. The bonding pair of electrons, the bonding electrons are 1, 2 and 3. But actually they want to bond. They want to form a bond, but they are not forming a bond. So they will complete their tendency to make a bond. So this would go here, and it will make a bond with carbon. With the result, what would happen? Nitrogen loses its electron, it becomes positive. Okay, so what would happen? This as a whole with the electron pair, this as a whole goes to nitrogen and combines with it. So what would be that we get? Let us see. We get oxygen. I written the oxygen here now. Carbon. This bond pair of electron has come here. So it's double bond. Nitrogen. The lone pair is still here, and R has come with its full pair. So this is the result now. Now we have attained the third product, which is isocyanate. So we have completed 3 steps, dear students. Now if you can see, a lot of water is being formed. Here also water was formed. Here also H2O was formed. So a lot of water is formed. So now it will be H plus OH minus. Here also the situation is little bit different. Look at this. This is nitrogen. This is very electronegative in nature. This is carbon. This is electropositive. Ultimately nitrogen will win this game. It will become negative and carbon will become positive. Now to the positive carbon atom OH minus will come and attach. So it will be something like this. And what will be the scenario there? N and the lone pair is still there. This pair has gone downstairs. There the H will get attached and this is the result. This is carbamic acid. Carbamic acid. This is also a very unstable acid. And now what would happen? This H, okay, this H, it will go to the lone pair of electron here. It will go to the lone pair and this negative, when it develops like this, when H goes, a negative charge develop over oxygen, that will come here and this bond will be broken. So the net result will be CO2 plus RNH2. The lone pair is still there. So that is how you start with acid-amide and you end with your primary amine. Dear students, I hope you understood the class. If you have liked the video, do not forget to subscribe it. Thank you very much.